Welcome back. This is the second lesson recording for IM2, May 6, 2021. Now that we've explored what this value 6 did, the value that is being subtracted by x before it gets squared, let's see what happens when we change the 4. Okay, if I change the 4 to 6, what happens? Okay, so it goes up. What if I change that to 2? It goes down. Okay, what is the coordinate of the center of this circle here? The center is going to be 6, 2, and that's where the 2 is. As opposed to if I change this to say 5, where is the center of the blue circle? The blue circle center is 6, 5, 6, 5. Do you see some pattern here? It's the vertical position of the circle's center, right? That seems to be changed by the value that is being subtracted by y. So it circles vertical position. And you can, and then it's asking you, can you change the equation so the circle is centered on 6, -2? What do you think? Well, currently it's 6, 5. So if I want -2, if I put -2 here, if I put just 2 here, the center is going to be +2. Okay, so if I want it to be -2, I want it to be -2, which is really same as +2. So, and if I do the +2, so that's going to be my equation. Okay, so let's summarize what we discovered from Desmos. The equation of a circle in graphing form, and we call this the standard form of equation of circle. It's going to be x minus h squared plus y minus k all squared is equal to r squared, where h comma y, this value, whatever the number that you're multiplying from x before it gets squared, is the x coordinate of the center, and the number that you're subtracting from the y before that gets squared, the k value, is the y coordinate of the center. So h comma k is the center position of the circle, and r being the radius, and it's going to be radius square. So please, you need to be taking this down, and you should put a box around it so that it stands out. So then, can we figure out how to write the equation of the circle? We're going backwards, okay? So we know that this is the equation of the circle, x minus h all squared minus y minus k all squared is equal to r squared, where h comma k is the center. Identify the center and the radius. What is the center and what is the radius? To figure out the center, we draw a horizontal line connecting the widest point of the circle and this vertical line connecting the widest point of the vertical. And so that tells me the center is -3, 1. The radius is how far the circle is from the center. That's 4 units away, so radius is 4. Now we're going to substitute into the equation template. So h is going to be -3 and k is going to be 1 and r is going to be 4. So that becomes x minus -3 all squared plus y minus 1 all squared is equal to 4. Notice that, don't forget that there is a built-in negative sign right there, x minus h and y minus k. Now, does this equation form sound somewhat familiar? Yeah, remember the parabola, the vertex form? It had the x minus h all squared is plus k is equal to y. That was the vertex form, and that's where we came across h and k as well, right? It's actually a similar idea. We call this the conic section, and this is one of the conics equation. Okay, so again, then you simplify this equation, and that becomes, when you see a negative of negative or subtract negative, then that can be changed to plus, so it becomes x plus 3 all squared, and that plus y minus 1 all squared is 16. And now what if we are asked to graph the equation x plus 2 all squared plus y minus 1 all squared is equal to 36. Again, that's the equation template. So we need to rewrite the equation as, if we need to, into this form. Okay, so we want x minus and we want y minus all squared, and we need to have this plus in between both squared terms here. So this can be rewritten as, instead of plus, I can rewrite this as minus 2, and then y minus 1 can stay as it is equal to 36 can be rewritten as what squared? 6 squared. So then you can identify the center as the number that is being subtracted from x, which is negative 2. The number that is being subtracted to y is 1. So it's negative 2 comma 1. It's not negative 1. It's just positive 1. And this is negative 2, not just 2, right? And the radius is going to be 6. Now that I have figured out the center and the radius, I know how to graph this. So find my center here, negative 2 comma 1. And then from here, I am going 6 units in all directions, and then drawing a circle around it. Okay, now I want you to tell me in private chat. For the equation x minus 2 all squared plus y plus 3 comma y plus 3 all squared is equal to 4. What is the radius of the circles? Okay, which number tells us the radius? It's the 4, isn't it? Okay, so it's going to be what squared is equal to 4? And that is going to be 2. What is the center of the point of the circle? What is the number being subtracted to x? That's going to be 2. So it's going to be 2 comma. Now we need to convert this to minus. So it has to be y minus 1. Y minus minus 3. So the center is going to be 2 comma negative 3. All right, so now you're going to be working on equation of the circle practice, card number 11 to 16. In fact, you can go all the way to the end. Okay, what is the center point? Okay, so again, I am going to draw a line that connects the widest point of the circle. So that's going to be from, this tells me the center of the circle is 1, comma, y coordinate is negative 2. Okay, so center is 1 comma negative 2. What is the radius? How far are each of the points? Okay, horizontally I am going 1, 2, 3. So the radius is 3. Okay, so radius is 3. Center has the coordinate of 1 comma negative 2. So then what is the equation going to be? It's going to be x minus 1. Remember that negative sign is built in. Okay, and then plus y minus minus 2, which is same as writing y plus 2. So I can rewrite this as y plus 2 all squared is equal to r squared. R is 3, so that's going to be 3 squared is 9 here. Card number 12, again, draw your horizontal and the vertical point from the widest. Oops. Okay, so and the center is right there. So that means that's going to be negative 5, comma, negative 3. And the radius is 1, 2, 3, 4, 5. Radius is going to be 5. Okay, so what is the equation going to be? I hope you can figure it out. Okay, now planet location. Move the circle so that center is not on the X or Y axis. Okay, now move the point outside of the circle to adjust the radius. So I can move this. Okay, and I can also move the center as well. Okay, and that's where I'm going to place my planet, right there. That's my planet. Okay, there you go. It has a radius of 8. The center is going to be 8, 8, 8. Okay, can you write the equation of the circle for this planet? Well, the center is 8, 8, and radius is 8. So it's going to be x minus 8 whole squared plus y minus 8 whole squared is equal to, what is the radius? That's going to be 64. Okay, notice that I need to have the parentheses. If you do not have the parentheses, you're not going to get the correct equation. Okay, so the order, having the parentheses makes a huge difference. Okay, and I think you can finish card number 15 and 16. Okay, so 16, and I think you can do the rest yourself. Okay, try to figure out which is the right one. And this is just a fun activity. Next up, we are told that this is the standard form of a circle equation. Okay, and where h and k is the center and r is the radius. Why is that so? Okay, we can't just accept it as it is. We want to know why, because that's going to help us develop more of mathematical analytical thinking. So consider a point xy. It's a point on the circle. Okay, it can be any point on the circle. Remember that definition of circle is that it's a collection of all the points that is equidistant from wherever the center is. Center in this case is 0, 0. And we can make a right triangle from the center to wherever the point xy is. Okay, so that means we can create a vertical line down here and the horizontal line there. And this, what is this distance? What is this distance? That is represented by whatever the y value is. Okay, it's a vertical distance and that's going to have the coordinate of y here. What about this horizontal distance? That's actually x because it's the distance from 0. So this point is going to have the coordinate of x0 and this length being x, width of x, and in this case the height is going to be y. Okay, whatever the y value is, whether it's 3, 5, or whatever, it's going to be a variable y. Okay, and we do know the radius is 5. So we have a right triangle. What is the relationship between width and height and this hypotenuse of the right triangle? We can use Pythagorean theorem because that must be satisfied, and so that which says the width plus height squared is going to be equal to 5 squared. So in this case, the width is x and the height is y, so x squared plus y squared is 5 squared. All right, then what if we have the center that is not at the origin? How does that change? Well, the y coordinate, this height is going to be whatever the y is minus 1. And this distance is going to be x minus 2, whatever the x coordinate is minus the center here.